Should be right about now.
Got it.
We do. We got it. Hey, everybody. We are at episode number 94 in a row of the online SBAU Astro Hour, the weekly vlog podcast for the Santa Barbara Astronomical Unit, our South Coast Longtime Astrophysics and Telescope Club, which is meeting together live and in person again out at our beautiful benefactor and backer, Santa Barbara's Museum of Natural History. We were there Friday night. President and vice president on the screen here. We'll introduce everybody. We both got reelected. Our 94th program viewable on YouTube or through SBAU.org. So let's meet the movers and shakers again for December 15th, or pardon me, the 5th through the 11th. We're in early December. Hello again, Mr. President, Jerry Wilson, our webmaster for now.
Good morning.
Would not believe what we went through to get on the air with YouTube. Jerry is married to Pat Forgy, who I assume was watching our program because her name was up on the screen through Zoom. I didn't see
her. He was there.
All right. Pat Forgy is married to Jerry Wilson. He's our 5th year in a row president-elect. I'm vice president and now going into my 5th year. Chuck McPartland is with us. Behind us, behind him is the Flag of Ukraine outreach coordinator, who I just learned will not be at the board meeting, but somehow we'll have to make it without him. You may not have heard that, Mr. President, but he will be at the Star Party. In fact, we'll ask him about all that here in a minute. He's married to our merchandise manager, lovely Pat. And Tom Whittemore is on the screen. He joined us. He's married to Maureen, former Westmont College science instructor, retired right about the time of the pandemic and bakes bread now and does our newsletter, edits it anyway. There is Bruce Murdoch, who's a longtime active member. Bruce, good to see you. How's the Santa Barbara Theater Organ Society functioning again, meeting in person?
We're having, open consults again. We haven't scheduled the one for December yet. It's typically the second Saturday of the month from 9 until 11 a.m.
Okay.
So we have to work around the theater's schedule. If they got something then that's going to pay them money, we have to go to a different weekend.
Well, I'm assuming, Bruce, like the rest of us, you are an ardent fan of classical music, especially with a pipe organ, and take care of Bonnie and give her our best regards for the new year coming up. This week, we are going to visit some galaxies shaped like spindles and cartwheels, and a star that's part of a dog, plus an asteroid that sounds like a hamburger. And we have a last minute breaking late evening target to talk about, missing addendum Kemble's Cascade.
All right.
However, the man sends us sillies, little silly cartoons forwarded by Mr. President Jerry Wilson that we'll start with just to get you in a good mood, ladies and gentlemen. These are, it's just the credit card ones. A couple aliens are at the cash register in the store. One creepy creature says to the other, "Hey, we're in luck, Zorko." Apparently they take Visa, MasterCard, and Uranus Express. Wonder where they keep it on their pimpled bodies. That's good.
And their spacecraft is smoking outside, so it's an emergency stop.
Oh, is that what it is? Okay.
Yeah.
Okay. Let's go to the next. This is the kitty cat one. Death on Mars. Curiosity killed the cat. Certainly did. There was one of Chuck's felines bites the big one on the Martian surface. Here are, these are the dogs in space. A couple of alien canines cruising in the cosmos. Does get a little noisy on board. And so finally, the female pilot dog has had enough. No need to howl at every moon we pass. Bruno, Fido, whatever.
Rex.
Oh, and I like this one. They're trying to make their way out of either a large landscape maze or
they're getting lost in their own crop circle.
Crop circle, that's what it is. Those are aliens or us. Have you ever seen one like that, done like a maze? Do they do mazes in those fields?
Well, I've seen crop circles like that, but they're not made by aliens.
I've never seen them as a maze. I've seen them as designs.
Okay.
That's exactly, it's done by somebody pulling a board on the grass.
It gets very boring out there and fun sometimes.
I keep thinking you're gonna run out of these, but there's probably just a whole wealth of. Okay, now this is interesting. Old Little Caesars ad, photo of Dad with buoyant telescope. What was that for? A brand of telescope?
Little Caesars, it was a pizza delivery thing. But you see, he's got the telescope backwards. He's looking at the Groin Nebula.
Yeah.
This is the bottom of the telescope. On a Newtonian like this, you look in the top end. But a lot of people that are not familiar with telescopes don't understand this. They assume you always look in the bottom end of the telescope and out the top. Even though they can't get it to work, they don't turn it around. I've seen this in the movie, what is it? Something in Seattle, Love in Seattle, Lost in Seattle.
Sleepless in Seattle.
Sleepless.
That's it. They have one in the background and it's pointed down at the floor too. And if it's a Newtonian in there, there's a 50-50 chance it's going to be pointed the wrong way. So people somehow in the prop department, they don't get this. The only one that had it right, I think, was Contact.
Are you telling us that in the part that's at the top in the photograph, the black round part, there's a mirror?
There's a mirror here that reflects light down to the top end here. And see, there's the finder.
Yeah.
It's eyepiece. And so this is typical for advertising and movies if they get a Newtonian upside down in the thing.
But at least they mounted the finder the right way.
Yeah. They
Find that they
you can hear
reverse
the amateur astronomers in the audience. You can hear them all chuckle when this comes up.
I thought it was a lightsaber because it's so lit up.
Yeah.
Well,
Well, it's got this lantern down here in the front. And so it's illuminated, and that's the brightest thing.
So it should be reversed and they should, I like this one. So the three wise men, right, on their way to deliver the gifts.
Goods.
Yeah, right. We picked up the gold and the myrrh, but what on earth is that? That's supposed to be frankincense, isn't it?
Right.
All right, I've thought of
Have to read
that.
the fine print. Okay.
Okay, levity is our us, and I'll tell you right now, Mr. President, unless you want to go stage by stage with the way you laid out your incredible talking points, we will jump from galaxy to asteroid to star or planet, back to galaxy again. Asteroids are beautiful.
You're the MC, whatever you like.
That's right, Mr. President. Don't ever forget that. And I'm also a heartbeat away from your job. Well, then let's prepare to go from the spindle to the cartwheel. Can we keep that sort of, going to visit the 8th largest constellation, M102, magnitude 10, NGC 5866, otherwise known as a spindle galaxy. Wait till you see.
Oh, spindle, you said cartwheel.
Well, that's where I ended up. We can go there next. Is this the cartwheel? Come, you go
We're going back to the spindle, Ron.
Yeah.
There it is.
That's the one I thought. So that starts out our talking points. Spindle galaxy.
This is a view you will not see in a telescope.
Really?
Yeah, this is very high, very large telescope, possibly the Hubble.
Okay, and so we're definitely.
You get the spindleness of it by seeing all this. The spindle galaxy is a tricky one. It's M102. If your catalog has an M102, the Sky 6 does not have M102. I had to do some hustling to figure out what it was. So it's NGC 5866, also known as M102, Messier 102. And you can see here, it's in the northwest at 7:30 in the evening. So it's going to set pretty early in the evening. So it's quite a challenge. You would have to have a very, very good western horizon. This is the northwest.
And not have the moon that we have this week.
That's right. So to compensate for that, I put in a much easier target for the evening.
Oh, Kimball.
This is Kimball's Cascade.
That's beautiful.
It's, let me show where it is first. It is right here.
Right.
And
Kimball. And Kimball Parlous.
Yeah, Kimball, thank you. And the pole star is up here. This actually never sets for here in Goleta. It's always up at some angle. because it's so close to the pole, it just rotates around.
Mhm.
So,
Great in binoculars.
Yeah, it's
That's-
absolutely
oh yeah,
it's essential to see this thing in binoculars. And you can even pick off 1502 at the bottom, that little splash open cluster.
That's the moon, that the bright part.
yes, the moon is going to interfere with these, but this is stars and not nebula.
This
Okay.
is a lot like Alley's braid in the Pleiades, is it not? I mean, they're
But-
just happenstance.
But much larger.
But it's a way larger than that. Yeah. It was discovered by a Canadian. I think he was a priest, right, Chuck?
Yeah, he was a Jesuit priest, I think.
Yeah.
And this is the cascade of stars with a roughly linear lineup.
It's Lucian.
They are-
Lucian.
Go ahead.
Lucian Kemble died in 1999 at about our age, gentlemen. And we call it the Kemble's Cascade. And I've never heard of a constellation called Camelopardalis.
It's the giraffe.
It's the giraffe, Camelopardalis.
It looks like it should be the camel, but I always have to remind myself it's the giraffe.
Well, it's the leopard.
Well, that
and
means, that name means spotted camel. And that's what
Okay.
they used to call giraffes.
And at the end of the cascade, you can see the 1502 right there. And if you put a scope on there, you can actually see 1501 in the background.
But those are 20 stars in a row or stellar systems.
Oh, they're spectacular. I saw them. I've seen them a lot, but one of the most spectacular views I ever got of that was in the Utah desert, just binoculars late at night in the summer. Absolutely incredible.
Yeah, you can see 1502 here is labeled as the Jolly Roger.
Yeah.
These stars are not associated with each other. They're all just an accidental alignment that form an asterism, but not a constellation.
Right. Wow. But they're
Absolutely
nice.
gorgeous.
None of them are close.
Tim just piped up. He says it seems to him like a stone dropping into a brook.
Yeah. Yeah, I've often described it as a little splash. Pretty
Uh-huh.
A line of stars makes a splash. I thought that would be
At
round.
1502, NGC 1502, that little open cluster at the base.
Oh, I see.
Right there,
Got it.
and also right there.
Yep.
Okay.
I've never heard Jolly Roger before, but that seems to be a good description.
I don't know. I never heard it before either when this came up.
Well, that's the name of our asterism, the Jolly.
No, that's the
No.
name of 1502,
Yeah.
the asterism of that tiny splash at the end. But the whole thing is Kemble's Cascade.
But asterisms don't always portray something like a shape or an animal or anything. This can just be a line of stars that becomes an asterism, right?
Right. And Ron, I always thought of this as basically, a cascade, a waterfall, and then swoosh right at the end is your little 1502.
Well, it certainly puts the belt of Orion to shame.
I think so.
Only three. Wow. And that, so you inserted that about the Kemble's Cascade
Mhm.
and 20 stellar systems in a row, 5 times the width of the full moon. And poor old Lucian, was he an astronomer or professional?
Sure looked up.
He was an amateur.
Yeah.
Was he an amateur? All right. Okay, can we go from there to the cartwheel?
We lost Jerry.
Uh-oh.
Oh dear.
Boy, Ron, don't forget to tell folks about the occultation. I'm sure that's part of the picture of
Yeah.
Mars with the moon on Wednesday.
It's in there. The initial release that Jerry put out had it on the
Okay.
wrong date. So that must be
Okay.
Astronomy Magazine.
The other thing that's interesting, Chuck, is that on the 7th, we get the earliest sunset. Oh, as you know, on the 7th, Mars is at opposition, right? So it's just opposite the sun, really pretty.
And
Busy
you can really-
day.
You can really see things.
Busy day.
You can really see in your telescope different mares on Mars.
Well,
I
they're not
have.
called Mares, but you can
No.
see some features.
Features, yeah.
They're called mares in his talking points. Mare
Well-
Sumerium and Mare Elysium, are they on Mars or on the moon?
No, those are on Mars.
Well, they're
Yeah.
called mares.
Yeah, some of them are,
Oh, okay.
but others like Syrtis Major aren't. So
I would argue Maria.
yeah,
the
Maria
plural.
for plural.
Yeah.
Maria is plural, okay.
Mhm.
But the North Pole goes from dark to white to become a polar later as, here we go.
Here we go.
Jerry's
All right.
coming back to join us. How you doing, Mr. President? Congratulations on being re-elected and joining us again. Can you hear us?
Yes.
There you are. We've been filling time till you came back.
Okay.
All right.
Apparently someone was dusting our modem connection downstairs.
Hate that when that happens.
Yeah.
You know what? We were talking about Mars. You might as well join the conversation. It's gone over to opposition and plus occultation.
Yeah.
You really call it that just because the moon, a full moon, or any size moon?
No, there's some tricky language in here.
Because it
So let's
probably occults
see.
a lot of things. Okay, catch up. It'll be Wednesday night anyway, the 7th.
Mhm.
From 6, in our time, it's basically 6:30 to 7:30.
Yeah,
Not 11 p.m. like it says in the talking points.
that's for the East Coast.
Okay,
Notice,
Oh,
Ron,
did it say 11 p.m. in the talking points? Sorry, I missed that.
that, yeah,
Well,
notice.
the first
notice-
one actually had, the first one you sent out had the wrong day for it.
Yeah. Yeah, because it's in the AM on the East Coast. I had to change the day.
And Ron, noticed that it's advertised a 1 hour occultation, which just justifies the fact that the moon moves through its diameter every hour.
oh yeah, right.
This is a picture from Damien Peach in Australia with
Wow.
a 14-inch.
He's in Britain actually, but he
Excuse me, I
has
always
a
do
remote
that.
scope in Australia.
Yeah.
Uh,
So anyway, this is a picture he took of the face that you're going to see
mhm.
at when it's in opposition, because it rotates every 24 hours, roughly.
Mhm.
So this is an excellent picture, and it's features that you should be able to see with a normal small scope, 5-inch refractor, for example, let's say. This
Provided
is,
it isn't turbulent.
yeah, providing your seeing is good enough.
Mhm.
This shows where it is in the sky, a nice astro photo. The Pleiades, it's in Taurus.
Well,
Yeah.
that's not where it is now, but
This
Close.
was in Taurus, yeah.
So in essence, we're catching up with in our orbit and passing it, and we're going to pull ahead.
That's correct.
Mhm.
Yes.
Okay.
Now this shows. Let's see, when does it show? This is
7 p.m.
7 p.m. December 7.
So Mars is actually behind the moon.
Yeah, and you see actually in this one, the Sky 6, it's got Mars and the moon coinciding with each other.
Mhm.
So this is in halfway through. Although this photo seems, or this plot seems to show Mars starting to stick out, but I think that it shouldn't be that way.
Well, that's a side where it'll disappear. So
Okay, yeah, that's right. It should be gone by this time, by 7.
yeah, it'll be right in the middle of the moon, of its passage.
Right.
Well, is the occultation of Mars by the moon something that is far more rare than, say, an occultation of the sun, which we call a a solar eclipse? Do we get solar
It's
eclipses?
rarer, yes.
In other words, normally, most of the time, the moon would go right by above it or below it.
That's
Right.
right.
Mhm.
Okay.
These are spectacular. They seem like they're innocent little events, but they're really quite spectacular. I remember watching one of my first sights when I became an amateur astronomer in 1960, was watching the moon occult Saturn.
Mm.
And you really get a sense of the distance of these things, how big they are and how small they look. It's very dramatic in my view.
Especially Saturn.
Yeah.
How often does Saturn go edge on and we can't see the rings?
Every 15 years.
Is that right?
Yeah.
Maybe. I wonder how that works. Is it on the other side of the sun or our
No,
side?
no, Ron.
No.
It has a 30-year orbit around the sun.
Mhm.
And that's when its equatorial plane happens to point at us, is on each side
Right.
of its orbit every 15 years.
I wonder how long it took Galileo to figure it out.
He never did.
He never did. But he never got rings either. It was always ears, wasn't it?
Right. It wasn't until almost, I think, 60 years after that Huygens in Holland with a better telescope figured out it was rings.
Yeah. He always referred to it as a planet with ears or with jug handles.
Yeah, handles, because he used the word onse, which is handles in Latin.
Yeah.
But Huygens never did know about the moon where his namesake probe landed, did he?
He saw it.
Oh, he did.
Yeah.
The probe?
The moon Titan.
Yeah.
Titan.
Yeah.
By the way, I didn't capture it. I should have for this morning, but the James Webb is taking very nice pictures of Titan.
Titan. Yeah.
And they showed a set of photos at different layers in the atmosphere of Titan.
Well, we saw that actually at the meeting on Friday night in the planetarium. Chrissy put them up on the dome.
That's right, she did. And so when you have an instrument that takes in different spectral bands, it takes pictures at different depths in an atmosphere. That instrument technically is called a sounder. Rather than it's just an imager that takes pictures that's tuned to different layers in the atmosphere.
Well, one of your pictures in your talking points was taken by the James Webb, wasn't it? Not sure if it's this subject we're on right now, but I'm making a note of it.
No, we'll come to that.
All right, what is this?
This shows pictures of Mars of Jezero crater, and this shows. Now that we need to talk about the opposition and the occultation. The closest that Mars got to the Earth was about 2 days ago in the orbit, and tomorrow night, or Wednesday night, the 7th, it'll be at opposition. So will be exactly between the Sun and Mars. So they're slightly off in that sense. The disk was slightly bigger, but you'll never notice the difference a few days ago where we were closest. But this is a close-up of Jezero crater where Perseverance has landed. And they're finding now organic molecules in the debris from this delta that flows out into the crater. So there was definitely water. You can tell from the flow pattern, there was definitely a lake here at some time, quite a while ago. And then there's also I didn't get a wider shot of this. There's also a hypothesis, this is a different place, but this shows an identification of shorelines or a body of water that were temporary shorelines, not like the one that had a delta. Here's the flow pattern coming into this lake, and here's a flow pattern either going out or coming in also. But these are different high water marks, the yellow and the red. And these are believed now, the hypothesis is that these are due to an asteroid hit that was very similar in size and power to the one that produced the Chicxulub crater on Earth. It's called the Pole Impact Crater. And it produced, they have the mechanisms for how this could be done through modeling. It's an interesting read on the internet. But these produced, at different times, they produced different tsunamis on Mars in this lake bed. So it had a very wet past. And things are looking good for finding past evidence of life, in my view.
And you could see Pole Crater in that image, the previous image, as kind of a mostly submerged. Yeah, there's the arrow pointing to it. You can see just a faint ring of it.
Mm-hmm.
That big Yucatan crater was produced by the one that took out the dinosaurs, wasn't it?
Yes, that's right.
55
It was a
million
big
years.
event. Maybe so. I think the probability looks grim for finding dinosaurs on Mars.
Yeah.
So this was a lake, or there was a lake here, and the asteroid hit right there, and it produced these tsunamis that then drained back into the lake.
Wow. And I believe we learned last week that there is magma under the surface of Mars, perhaps, or at least there's Mars quakes.
Yes, the Mars quakes suggest that there are bodies of magma that can move underneath Mars. They don't have any plate tectonics to speak of that I've heard of.
So that asteroid or whatever it was that hit produced this Mare. Is that what we're looking at? A Martian Mare?
No,
The lake bed.
Oh, it's
that's a lake bed that was already there. And you can see that dim ring around where it says Pole Crater is the crater that impactor made.
Mhm.
So there was water on Mars. It just went somewhere. It all evaporated into space, I guess.
Or absorbed into the surface and went into space, yeah.
Mhm.
Got it.
And of course, it went into rusting the available iron to produce iron oxide, which is red, and that's why the planet's red.
Wow.
There's lots of iron ore up there.
Oh, that's why it's red.
Yeah.
Well, a quick silly side question, if you don't mind. It's got two little dinky moons, Phobos and Deimos.
Yeah.
Can you ever see the shadow of it going across Mars's surface?
Too small.
It is.
We do have pictures from the rovers and other stationary probes up there of the moons passing in front of the sun.
Yeah, yeah.
Yeah, mini eclipses.
Yeah.
But you can't see it with a telescope from Earth.
I think they're on the borderline between eclipses and occultations.
Yeah,
Mhm.
Wow.
ecliptations.
Yeah.
But according to your talking points, you can see the Mares. You mentioned two of them on Mars with your telescope, but you can't see things like the big long canyon or Olympus Mons. You can't see things like that, can you?
People see hints of those. You can see clouds that form over Olympus Mons.
Clouds?
Yeah,
Mhm. It's
You
pretty
know
tall, Ron.
What?
It's very tall.
it's
Yeah.
3 times higher than Mount Everest.
Well, clouds are made of water vapor. What are they made of on Mars?
Water
Carbon
vapor.
dioxide
Oh,
and water.
Yeah.
Mhm.
okay. God, the way planets look and everywhere, they're all different. It's different
Some
colors.
people look at this and see canals.
I know.
Matter of fact, from these features right here, 2 of the canals took off and went this way.
Yeah.
All right.
Of course, Ron, the problem is when Schiaparelli looked at those things, he used the word canali, which means channels. It's
Right.
not cannoli. It's not cannoli. It's canali.
Yeah,
Well, we could easily come up with some names for them if there were canals. One the Suez, the other called the Panama.
So was Schiaparelli the one that said, leave the gun and bring the canali?
yeah,
Right.
Canales.
Yeah, don't forget the canali,
Yeah.
which is funny because I'm making ciabattas tonight, Italian bread.
Oh, okay.
Should learn how to do baguettes.
I did. I made 2 yesterday.
Yeah, the baguettes apparently are very, very strictly controlled in their size, shape, and composition.
And Jerry, most difficult thing I ever tried to bake.
Was the
Right.
They're yeah. I don't have the knack for them quite yet.
It's very simple. It's flour, yeast, and water, I think.
4 things: flour, yeast, water,
Salt and sugar.
salt, and salt. No sugar. No sugar.
No
Ron.
sugar?
Yeah,
Okay.
yeah.
But you have to
I
keep.
think Napoleon used them as
folding
weapons.
it.
What'd you say, Bruce?
I said, you have to keep the dough, you have to roll it out, butter it, fold it on itself, roll it out, butter it.
Yeah,
fold it
no-
on
no
itself,
butter.
right?
Butter. No
No
butter here.
butter.
Nope.
And if you made it,
It's interesting, just a little side note here was in the New York Times last week, UNESCO came up with a whole bunch of cultural markers, and one of them was the French baguette. There's a wonderful article on the baguette if you want to read the history of them. You know,
oh yeah, it's recognized as a World Heritage something or other.
Isn't that cool?
World
Yeah,
Heritage
Napoleon-
cultural item.
Yeah, Napoleon's troops used to carry them on their backs.
But part of it is the shape. It's shaped like a muamua. If it were round, it wouldn't be a
I
baguette.
think of it as a skinny torpedo.
Okay, we're drifting here. We're drifting.
That may
Okay.
be what Oumuamua is.
Yeah.
Mr. President,
Yeah.
this
There we
was
go.
a little, not much to this, but you're gonna have to give us, can I read this one?
Go ahead.
129 before Common Era. Even before Christ, Hipparchus gave us the first distance to the moon. You don't tell us what it is, but you tell us how he got it. What did he come up with?
Well, according to this formula, he came up with about 5,000 miles, which sounds a little wrong.
His accuracy was the problem. The technique is fine.
Yeah, yeah.
Parallax? Is it parallax view?
Yeah, there's a person standing here at Cyan.
Saying.
Yeah, and another person standing at Alexandria at the same time. And they're looking at how much of the sun they can see around the moon at that instant.
Yeah.
And so they equate the angle, and that gives them, they know the distance here on Earth, and they approximate the arc length here as the sine of the angle, which gives them about a half a degree. Well, that is, the moon subtends half a degree. And so they figure that out for small theta. That means that this is their approximation. Sine theta is equal to theta. And so the distance here, d, which is to the moon, or the distance between Alexandria and Cyan, ratioed to the distance between the Earth and the moon, is that angle.
Yeah.
And so he figured that out. He did not have precise timing of how much you saw it at that instant. Their cell phones were down.
Yeah.
But the technique is quite accurate. And apparently this is beyond flat earthers today. So
Yeah.
He did a really good job of estimating the size of the Earth, though.
Yeah.
From shadows. He did it from shadows of poles in those two towns too. Those two towns.
And they had an approximate distance where they used an ancient Greek measurement, I think stadia.
That's correct.
Oh, yeah, stadia, yeah.
And some poor sucker had to walk it out.
Yeah. And today, he actually ordered a bunch of troops to walk it out.
Yeah.
And today they estimate that at 500 miles, but they don't know for sure what a stadia really was, how long it was.
Yeah.
And so depending on how you measure the stadia, he could actually have made a pretty good, an even better approximation of the Earth's.
It was super clever. Very clever way of doing it.
You do it in reverse, and that way you can define the length of a stadia.
Yeah.
We can, yeah.
Yeah.
Isn't stadia the plural of stadium?
Correct. It is.
So it's like stadiums. But now, who was the ancient that came up with a similar method of measuring the circumference of the Earth?
It was the same. That's what we just talked about with the pole.
This same person.
Oh, it is Hipparchus?
Hipparchus.
Oh, I missed that part. Okay. So
this is the same thing that we discussed, I think, 2 times ago about they just found parts of his original ancient manuscript.
Right.
Why was he off? Why didn't he get the correct answer?
Because his instruments for measuring these lengths and positions at the right time was not that accurate.
Mm-hmm.
And is it true? 5,000, 6,000 miles, you say, Chuck, he came up with?
Well, that's if you do this formula with the 1/10, it's about it's about 500 miles between Cyan and Alexandria.
Mm-hmm.
This is part of trigonometry, isn't it?
Yeah.
Mm-hmm. Mm-hmm.
Wow. So we know it's about 240,000, right?
Yeah.
Mm-hmm.
And part of my little talk Friday night was coming up with the speed of the moon in its orbit, 2,200 miles per hour.
Okay, now this one I put in. This one I put in because it's a pretty picture.
Is that the cartwheel?
This is a James Webb picture.
Of what?
The cartwheel.
Okay.
Yeah, you can see the many spikes up here.
Wow.
And this is the Cartwheel Galaxy. This was discovered by Fritz Zwicky back in the 30s. And he goes, WTF. And he said, we're going to have to wait till we understand the dynamics better to figure out what this is. And through collision theory and approximation or modeling, we now know that this is a direct result of an interaction between this galaxy and another galaxy, possibly one of those that's whipping off into the distance here.
The picture looks almost fake.
Yeah, that's not exactly a bar in the middle.
Yeah.
Well,
So you can get this same picture from multiple telescopes with different emphasis. So you know it's not a fake,
yeah.
but it might be over processed or what.
Okay, that's a better term.
Well,
Yeah.
this is
Process.
from James Webb, so it's showing you a lot of the dust detail that you don't see in others.
Yes.
Well, you don't see pinwheel arms.
Well,
I
it's not a
see.
spiral galaxy.
Yeah.
The central galaxy may have originally been one, but this seems to be a case when it was hit dead on, like right in the center by another galaxy. And this is basically a shock wave traveling outward.
Mhm.
Because you can see a barred spiral up above it.
Yeah.
Looks like one.
One or both of those two little galaxies at the bottom may have passed through it.
May have. I don't know the relationship to these
Yeah.
three. They might all be interacting gravitationally.
That
Yeah.
lower right one looks like it suffered a similar impact. The lower right
Yeah.
there. Yeah.
And this is what splattered off.
There's another great cartwheel type galaxy called Hoag's object.
Oh, yeah.
And if you look at the picture of that, the Hubble picture, within the circle of Hoag's object, if you look in the background, there's another cartwheel galaxy. So
Huh.
it's really cool.
Okay, so something went right through the center of two galaxies.
Wow.
Or the one galaxy hit another galaxy and went, oh yeah, in that case, yeah. It may not have been the same impactor, but
No, just joking.
yeah.
I have a question about the colors that are shown, because I thought James Webb saw basically in the red and then infrared and the far infrared,
Yeah.
and they artificially colored the infrared images to make them look visible.
They do,
Right.
and they color code it with the filter they used.
Well,
So go ahead.
apparently, Mr. President, there are two other catalog numbers that I don't remember seeing, not just M's and NGCs. There's ESO 350-40 is what this is known as, or PGC 2248. Are those?
Weren't those defined in the talking points?
It may have been. I thought I.
ESO, Ron, is European Southern Observatory, and PGC is it's going to be some like Pulkovo Galaxy Catalog. You know, it's some observatory starting with a P.
Yeah, Pulkovo in Russia.
Old man Messier never got a shot.
Yeah, if I missed it, I apologize. I try and define everything that's new like that.
Well, that's why we have the program, gentlemen. We learn these things.
Yeah.
This is not a Messier object.
No.
No,
too
it's
dim.
not bright like that.
No.
I believe we learned that Messier saw his stuff with naked eye or with a telescope.
No, with a telescope, with a
Small
3-inch
telescope.
telescope, roughly.
He did have a telescope. Okay. So he was post Galileo, obviously.
Yes.
About the
He
time
had
of the
a fairly
American
good
Revolution.
telescope.
Well, is this part of a big, huge group? I want to say asterism or,
You mean galaxy cluster?
well, yeah, well, no, yeah. No,
No, I just picked this individual galaxy because it looked really good, and it's from James Webb. It's in the pretty pictures department.
looks like a slab of ham on the end that you cut off.
It looks like an egg that's been turned over too hard.
That
Yeah.
too.
Tim Crawford says it looks like a pizza crust with white avocado.
Yeah.
Be
No,
interesting.
there was white avocado. Anyway,
Be interesting to compare it to a Hubble shot. If Hubble saw it, would it be that much
Well,
difference?
there is in the observatory, Chrissy can put it up, but there's a superposition of both a Hubble image of this object and the James Webb in the different wavelengths.
But the big one is called the cartwheel. The two little ones, they don't have names,
They have names, but they're not the subject here.
right.
and they're beyond, it looks like.
So what would you like to do next?
Well, let's see. We did cartwheel, we did Mars, we did Hipparchus. I just want to read one thing from your talking points, see where this applies. This is back on Mars. Do you mind if I just read it? We don't have to.
Go ahead.
Up. Recent analysis. Oh, you did talk about this, the Chicxulub crater. I was going to read that. Oh, asteroids are us. 324 Bamberga. I've never heard of it. Can you guys see it in your telescopes?
Sure.
All right, it's near Algol, the demon star. My God, there's a demon star. 50 degrees high in the east, an hour after sunset. Algol is magnitude 2, an eclipsing binary star that gets dimmer as its unseen companion passes in front of it. Is it a black hole? You suppose?
No.
No.
Not a
Just an
black-
eclipse binary.
But you can't see it. It's a star.
Actually, I think, no, you can see it, Ron. You can see it in a telescope. You can't see it visually.
Right.
All right. But it's actually, I think, a triple system. And you have a small bright star that periodically passes behind a bigger, dimmer star. And so the whole system dims down for about 2 hours and then pops back up. And so Algol comes from Ras Al Ghul, head of the demon,
Right.
because they
Right.
noticed this dimming apparently. And they said, this is the eye of the Medusa monster winking back at the earth.
Yeah. And a deaf mute named Goodrick wrote about this star. Goodrick.
He was like
And-
17 years old and figured it out.
Right, and he died of pneumonia because he stayed up watching this
Oh,
thing.
well, too late.
Yeah.
How big is
So,
Ben?
you know Algol's got to be a bright star because it has a name. They don't
Yeah.
name obscure things.
What does it mean? It's ancient Arabic for what?
I just
Ghul?
told you, Ron, Ras Al Ghul, head of the demon.
Of the demon.
Yeah,
Oh,
that's why it's
We're
called
Ghul.
Demon Star.
Okay, got it. I didn't get that.
Now, near Algol, roughly where I put these words is
Mhm.
where this week the asteroid Bamberga is.
Oh,
It's in opposition. It's moving very quickly. It's not the brightest thing in the world, but if you like to track, it makes a neat set of images. If you take a picture every night for 5 or 6 nights or a week, you can follow that's how you identify which it is, because you can see it move with respect to the starry background.
mhm.
Wonder what that means. Bamberga. Is that a
Well,
McDonald's?
it's close to what a person from Brooklyn would say hamburger.
Yeah, for-
What's a weekend special at McDonald's?
Yeah.
Bamberga 324.
And it's about 130 miles across, Ron. It's one of the bigger asteroids.
Wow.
But it's not going to occult Algol.
No.
At this time,
Okay. But they, interestingly enough, they have what a dimming. That doesn't make it a variable star, but every 2 days, 20 hours and 49 minutes,
Mhm.
it goes through a cycle of its little dinky companion that we can't see with the naked eye.
Right.
You can,
Mhm.
it says unseen in the talking points, but that didn't qualify it. You can see it through a telescope. It's-
Yes.
And like
And
you
it's
said,
the small one that disappears is the brighter one of the pair.
Yeah.
so their orbits are edge on to us.
Roughly, yes.
yeah.
Mhm.
Interesting. How many
And this
asteroids are there that are
17-year-old
that-
guy, this 17-year-old Goodrick, this kid in England is the one that figured out what
Yeah.
was going on or postulated what was going on.
Yeah, he was a deaf mute.
Well, is the little guy on the other side that occults it bigger and thicker? It's like a white dwarf, a white, what do they call those, super dense?
Well, Ron, a white dwarf is a really small object.
Right.
I know.
This
what-
has nothing to do with white dwarfs. This is like a red giant star and a main sequence star.
Yeah.
Oh, I see. Okay, so the red giant is Algol.
Yeah. The white
Well,
dwarf.
the two
what
of them
our sun
together
will
are
be-
Algol,
Both of them, okay.
or the
So
three of
Ron, a
them.
white dwarf is what our sun will eventually become.
You would think they would have some system where rather than just calling it a star, they'd have a -2 beside it or -3.
Well, they do. Algol A, Algol B, Algol C, but you can't see them with your eye. And stars with names were given names because you could see them with your eye. They didn't know they were triple when they gave them the name.
Right.
Oh, okay. And more than half of the night sky stars are
Or
binary.
multiple systems.
Mm-hmm.
Is there a word trinary or?
Yep.
Trinary, okay.
And quaternary
Quaternary. Well,
and quintuplet.
well, as long as we're talking
Quintuple.
asteroids, Mr. Outreach Coordinator, have you been out occulting anything?
It's been raining here.
Yeah, it's been cloudy and raining, so no. And
I have identified 2 places that need weather stripping.
yeah. Oh,
But
Yeah, I
on
can
your
in your
verify.
observatory or in your house?
Observatory.
Oh, good.
We went through the house thing 20 years ago.
Yeah.
Yeah, and I can verify that Arcturus is coming up at 3 in the morning now.
Oh, okay.
Sirius. Well, if we were to run short of time, we only got Sirius to talk about the big dog Canis Major.
Mhm.
Is it possible, Mr. President, you could call up pictures of your new backyard telescope building? Is that in your system there?
Yeah, probably.
Well, then let's do Sirius, Canis Major, brightest star in the sky. Going to be sinking in the southwest a few hours before sunup. And it's blazingly bright A-type star. There you go, with a tiny dwarf companion again, often called the pup. Canis Major is, lost my place, home to a lot of deep sky stuff, from galaxies to star clusters.
It's interesting. There's a bright star cluster in Canis Major,
Mhm.
Messier 41.
Yeah.
Okay, and it's often called the Pleiades, in
Pleiades.
contrast to the Pleiades.
Yeah.
Yeah.
Well,
Because
it's
it's in a dog.
NGC 2354 is up there. That's a star cluster, isn't it?
Yeah,
Yeah.
open.
Yeah,
Well,
you
you're
can see
starting to talk
M41
about
off to the right
Sirius.
of it.
You what?
You can see M41 off to the right of this star
Mhm.
cluster.
Oh, yeah.
Yeah.
M41, yes.
But Sirius is the brightest. It's what magnitude what?
Minus 1.4.
Mhm.
Now, this is December 5, which is tonight.
Night.
But actually, this
This morning.
was this morning at 4:30, but it counts for December 6th at 4:32.
Hmm.
So, and this is in the east with rising of Sirius. So, I think it's in the east,
And it's called
south. Okay.
And Tim here wants to mention near where this cluster is, they're
Mhm.
kind of in the rear end of the dog. There's a star called Herschel 3945,
Yeah. Yeah.
which is a nice double, or at least visual double, that shows color contrast just like Albireo. So it's called the winter Albireo.
Yeah.
Huh. Is it in the cluster? Could it be in this
No.
photo?
No.
Okay.
Hmm.
So it's back up here somewhere.
Yeah, I
Yeah.
think it's higher up. But
Okay.
Tim's the star hopper. He would know better.
Yeah.
Or maybe Tom.
Yeah. Well, the star cluster that Jerry's highlighting right now, I've shown in my 85 millimeter to folks. They really liked it.
Yeah.
I think I've even shown it to Pat. Your wife. There it is.
Hmm.
Jerry, do you have the NGC on this one?
I do, 2354.
Yeah.
Okay.
Located 1.5 degrees east northeast of magnitude delta Canis Majoris in his orchestra.
Mhm.
And we have, there we go. Whoa. Fascinating stuff, gentlemen.
I always thought that Sirius was the shoulder in Canis Major, and I'm looking at the graphics on Stellarium, and that's where it's showing it also, not his eye.
Yeah, I've always heard it's the heart of the dog, but you'll see
Mhm.
different pictures all over the place. I don't think there's
Yeah.
any standard constellation reference.
Mhm.
But dogs, what
Well,
kind
my
of
measure
dog?
of how good is the seeing is I can see Sirius generally, even when it's really lousy. But
Here we
can I
go.
see the 3 stars that make up his head?
Yeah.
And then
Well, that's
it's
not
good
seeing, that's transparency.
Okay,
Seeing is more how much it's twinkling.
true.
That's half of that radio thing you can buy, XM Sirius. That's, they spell it the same way. Ladies and gentlemen, we are taking you to the backyard of Casa Wilson, named after a volleyball.
Wilson, yeah. A lost volleyball.
or maybe it was
That and Tom Hanks, right? He was.
Yeah. Castaway or something.
was it a volleyball or a soccer ball?
It was a volleyball.
Volleyball. Okay.
Yeah.
Look at that. Look where
Well,
he
this is a
lives.
good picture of your northern expanse, isn't it?
That's
Yeah.
actually southwest, right?
This is, the freeway's over here going this way. This
Mhm.
is, this wall faces directly north.
Okay.
Oh, okay.
So this wall faces directly west, or not faces, but points directly west.
Okay.
So
Okay.
this is the final stage of putting the metal roof on the observatory.
But there's got to be a slot up there to look through, right?
No,
No,
it's
the
a
roof
roll-off roof.
slides.
Yeah,
The roof is on rollers. It slides off.
right.
Oh, that's right. You said this. Okay, this is.
This shows the inside of the observatory, and here the roof is over here. It's now rolled off, just like a garage door opener.
Mhm.
Okay, what is the big bar sticking out of the right of that machine?
For the
That's
counter.
Counterweight. Counterweight shaft.
Yeah, you see the counterweights stacked up down here?
Oh, counterweights.
You put those on there to balance the weight of the telescope. And this is a 22 and an 1/8 inch ID ring that mounts right here to hold the telescope up. And this is my air chair, which is a customized drummer's chair that's sold by OPT for astronomy. But it's actually a
Raises
chair
up
that a
higher?
drummer would use. What?
It raises higher up.
Yeah, there's a lever on the side. You can lower it up and down and it hisses, and it's called the air chair. It's very convenient.
So the instrument's not really mounted yet. That's just
No.
a big. We're looking at.
Those are the rings that capture the tube on the right.
Is the telescope the one that you've been working on for a while?
Yes,
The
That's pretty.
since 2014. I don't like to rush. I don't like to rush into things. It's,
Who is that ugly fella?
I don't know.
Bunch of ugly guys.
Here we're putting together the telescope for the first time, and everything's out of balance. That's why everybody's hanging on to the telescope.
What is the tube made from?
What's that?
What is the tube made out of?
Carbon fiber.
Oh, okay.
It's 6 feet long and 22 and an 1/8 inch OD.
So you were able to find that rather than having to make it.
That's correct. So this is the these are the rings I showed earlier
Mhm.
that hold it up. Now we did put it in the observatory, and the thing, when it was in there and fully mounted, it slides down, so the tension wasn't tight enough to hold it up.
Mhm.
So that's where we had a Tiger team come in and put in an extra layer of felt lining inside the rings. And then that would hold it stiff enough so it wouldn't slide out of its own mount.
Mhm.
Chuck, Tom, and my new son-in-law, Jesse.
Ah,
Nice weather.
my understanding is that you don't really need a tube, right? As long as you have something to hold the parts apart, the mirror.
That's correct, but in my neighborhood, you do need a tube for,
Gray light.
yeah, for stray light because of the street lights and the neighbors' lights.
Is that it? Is that the big bang? That's all you could do? My God. Well, did you paint the wall?
Charles Schuler, who has the 20-inch Explorer Scientific scope, every time he looks through my scope, he keeps commenting how great the contrast is.
Yeah,
I said, yeah, you need some
baffling.
more extension on the front that's painted flat black.
Yeah.
Or a
So this is
shroud
my
around
extension
the-
on, this is my extension on the front. It's the upper cage assembly from an 18-inch job. And I've got the material that you wrap around the inside.
Okay.
And it just slides very easily on and off, and it weighs just a few pounds. So this is the front end light shield. We've got an eyepiece focuser back here, which will have a camera in it. And this is the counterweight for the focuser and the camera.
Wait,
Question
Jim
about
Williams-
I
Jim
thought
Williams
about
is saying
buying
he really
a
likes the
black
observatory.
paint.
Wait a minute, two people at once. Chuck?
Jim Williams is saying he really likes the observatory.
Oh, thank you, Jim. Bruce?
Yeah, I have a question about, the painting the inside of the tube, et cetera. They make an ultra black paint whose reflectance is virtually zero. And I thought about buying that and painting the inside of my Schmidt-Cassegrain more black. Has anybody done that? Does it make any difference?
I don't know. I haven't done that on an existing scope. I know that this this material is a sticky backed, what is it? Cladding?
Flocking?
Flocking. Thank you, that's the word. And it has extremely low reflectivity at very low angles, which most paints don't have.
Oh,
this is-
yes, yes.
This is the black paint that the tube came with, which they purposely blackened.
Uh-huh.
But I added this stuff, which you can see is much blacker. And it's from Protostar. It's great stuff. And this is similar to the stuff, if not the same, that Teleview puts in their telescopes. They don't have ring baffles in them like a lot of refractors used to have.
What was the name of that again?
This is from flocking from Protostar.
Protostar, all right. I'll look into that.
Okay.
I know Joe's used that on some of his scopes too.
Yeah.
and it seems to
I
work
use
well.
this on all my reflectors.
Yeah,
It
I'd use
works great.
Have you done this presentation on the Tuesday night Zoom, the telescope
is-
workshop?
He did this on Friday, Ron.
Yeah.
Know that, but that's what, this is the sort of thing that the Tuesday workshop is all about, isn't it?
Yeah. No, I haven't done it on the Tuesday workshop, but tune in tomorrow night.
Great.
Oh, actually, I don't want to take away the audience from Telescope Tuesday.
I don't think that's a problem.
If you live in the area, go out to the Camino Marketplace tomorrow night at dawn, at sunset. There'll be telescopes set up if it isn't raining.
Well, at 7 p.m. Yeah.
Yeah.
Well, a final question perhaps is, could you put in a dome like an observatory, or can you buy those pre-made, since it'd be very hard to build one?
Yep.
Yep.
But you wouldn't be allowed to put it up in your home, or as long as it's.
The HOA here is very strict about blocking anyone else's view. So if your neighbors complained about they like the mountains better than your dome's got to go. So we worked with our neighbors beforehand, for a year beforehand, to work on design and where and how high and stuff. They're very cooperative.
Well, it seems to me there's no reason why the world's telescopes couldn't be in block buildings, just like regular, hangars.
Many of them are. I like looking at the whole sky when I'm up in viewing things. And then I don't have to worry about this slit in the dome always lining up with my telescope or intruding on it while I'm taking pictures.
Right.
They have software that does that for you, but you have to instrument the dome.
Yeah.
But
And
now-
the thing about the dome is it helps cut down on any wind effects you might get, but that's about it.
Yeah.
But all those domes worldwide are on a turret, aren't they? They turn.
Not all of them. Some of them, the whole walls of the building turn.
Yeah.
Really? Okay, and then you just have a roof that slides across, Jerry.
That's right.
How did you build that? Is there a track that you can get down at Home Depot on both sides that it?
I had a company that installs garage door openers do it. It's basically the same system that opens garage doors, but that works on a cable, and it is we adopted a system that was on a roll-off roof observatory from an amateur in Germany. And we communicated with him, and we bought the same equipment that he used, but we bought the version that's built for US electrical standards instead of 220. It's very powerful. It works very well.
Yeah, it looks real nice, Jerry. I was going to say, when I was teaching at Evergreen in San Jose, we designed and built a sliding roof that also contained a dome. We had a dome and a sliding roof.
Yeah.
Well, is the computer going to go in there?
No, the thing is full of instruments, and the power is out there, and we have an Ethernet cable that goes from the inside of the observatory to my home modem here. And so we can operate the telescope from in the house, and all of the instruments, the camera and the rotator and the focuser and the telescope and everything goes through a hot hub and down to an instrument called an Icron, and that converts it all to Ethernet, and the Ethernet cable comes out of that and goes into our house.
Wow.
So you could save pictures somehow.
Oh yeah, this is intended to take pictures pretty much only. we built it real small and tight to fit in the backyard. And so there's not really room for someone to do all the gyrations you need to look through a Newtonian. So it's meant to operate cameras only while we do it from the house. The observatory is meant to be basically a box that the lid comes off of to store the telescope while it's not being used.
Jerry, you built a corrected Dalkirkham, right?
I'm halfway through a corrected Dalkirkham.
Oh, so that's not the scope in this observatory.
No, this is an 18-inch f3.9 Newtonian.
Oh, nice. Okay.
Is it homemade or is it made by somebody commercially?
No, I made it.
Okay.
Got all the parts. Different parts are made commercially.
Wow. There's very little to use a video on a telescope, is there? Other than an occultation, that's about the only movement in the sky you might get.
Video is low resolution usually. That's the thing. So you want higher resolution.
Really? We're talking pixels, aren't we?
Yeah.
Moving pixels.
Yeah.
Yeah, video is only 640 by 480 for me. So
You get the high def stuff that's
With still cameras, you can get effectively a video. You know, you go out and you take a picture of Andromeda every 100 years, and you put it all together, and you can see Andromeda rotate. You know,
Motion photography.
That's pretty good.
Well, then let's make it a plug for tomorrow night, 7:30, right?
Yeah.
7
How
o'clock.
does members jump on? Just go to SBAU.org and it'll tell you how
Yeah.
or why. Congratulations, Mr. President, your 6th year, my 5th. Congratulations to me.
Congratulations on being vice president again.
Of course, thank you, my friend. And Chuck, it's a good thing you don't have to run or you'd be contesting the election, wouldn't you?
No.
Well, so all of you, take care of your wives, and we're going to do this again in a week. It'll be number 95. So Bruce, thanks for calling in. Tom Whittemore, President Jerry Wilson. We'll see you on the podcast next week. SBAU Astro Hour. Over and out from Barry.
Over.
Thank you.
Bye, guys.
Right, bye now. What do I do here?
Dying slowly, sinking into the Maureen's iPad. What is that?
Oh.
I think because we lost the president at the beginning of the program, that he now can't get out. We're constantly here. Bruce, I'm glad you're back with us.
You know, I'm trying to turn this off also. It doesn't want to let me.
See the little X in the corner? Let's try that.
I don't see a little X in the